Locked on. I've executed the launch. The target is destroyed.
The KAL incident provided the world with a vivid demonstration of America's eavesdropping capability. But if America's network of spy machines is to reduce international tensions, it must have a counterpart. But just how good is the Soviet reconnaissance system?
We fly Cadillacs, they fly Chevys. They're very reactive. We have got very highly sophisticated, large reconnaissance satellites with lots of miniaturized stuff in them that do lots of exotic things. They're not quite as exotic, but they send up a lot of them. In September of 1985, they had 10 reconnaissance satellites in orbit at the same time. Their weakness is they're not as good in computers as we are, and that hurts them a bit.
The Soviets use their Soyuz spacecraft for science and space exploration and reconnaissance. It's widely believed that cosmonauts conduct spy missions. The Soviets also use an unmanned version of the Soyuz for reconnaissance missions. The orbital module, instead of returning cosmonauts, brings back surveillance photos. But for gathering missile data, the Soviet Union relies less on spying from space than does the United States.
In collecting telemetry from missile tests, they can use surface ships that are driving around out in the Atlantic or Pacific Ocean, since our missiles are tested over the ocean. We can't do that, since Soviet usually test their missiles over the Soviet interior, where even aircraft can't get at them. So they can simply load up a ship with electronics to collect information on our missile tests. We have to develop a very sophisticated satellite to collect similar information.
As sophisticated and extensive as America's intelligence system is, it faces many problems. With tens of thousands of images and messages recorded daily, are human analysts drowning in information?
Well, the problem has always been the United States, particularly the NSA, doesn't have any problem collecting information. They have incinerators that are designed to burn 40 tons of paper a day, for example. So collecting data, collecting information has never been a problem. The problem has been analyzing that information once you collect it.
It's hard to say. No researcher, which is an intelligence analyst, ever would want to tell you that he's got too much information, because they always want that one more clue that they may find is the most valuable one. And that's where the computer comes in, and we just couldn't handle this without computers.
A civilian application of computer techniques to combat the flood of images is seen at the Jet Propulsion Laboratory. Here, technicians compare pictures of the same site taken at different times. But in reality, it is the computer that first detects the changes. Comparing masses of digitized images is just one of the spy tasks assigned to supercomputers. This machine can perform over 150 million calculations per second. The National Security Agency reportedly has row after row of them. Besides information overload, another problem is that spy machines themselves are vulnerable to espionage. The Soviet Union may know more about U.S. satellites than American citizens do. Christopher Boyce gave away secrets of the Rhyolite satellite. William Campile sold the Soviets the technical manual for the KH-11 for $3,000. And Ronald Pelton compromised a host of NSA secrets, including the existence of a critical underwater listening device used in tracking Soviet subs.
7 feet per second, altitude 4.3.
But the most immediate problem facing America's spy system is a basic one: getting off the ground. In 1980, a secret U.S. defense study forewarned that a failure of the space shuttle could be disastrous for the entire technical intelligence collection effort. The Challenger tragedy grounded the next generation of imaging satellites, which are presently too large for unmanned rockets. Two other attempts to put into orbit what were believed to have been the last remaining KH-9 and 11 satellites failed.
As of right now, we have got one KH-11 in orbit, and that is getting close to the end of its useful life. They're being very careful how they use that satellite now. You don't just keep running it all the time. You've got to husband your satellite very carefully. They keep it up as high as they can to prevent atmospheric decay, and they don't work the system any more than they have to. So to that extent, it is in trouble. To the extent that the KH-12, is produced and ready to go, we will bounce back.
For the future, America will monitor weapons and arms control compliance with a yet-to-be-launched KH-12. Its existence is still officially denied. The KH-12 is believed to be similar in design and size to the space telescope illustrated here. But instead of pointing to the stars, the KH-12 will look back at the Earth. It is believed to possess a tremendous ability to spy down to a resolution of inches, as well as being able to see in the dark.
Meaning we'll be able to get decent, although not as good as usual daytime photography at nighttime, which means that if the Soviets are testing a missile at night or being involved in troop movements or anything else at night, then there'll be a possibility of getting those photographs.
For 3 decades, spy satellites have trained their lenses and antennas mainly on stationary missile pads. But now the missiles have started to move. The Soviet SS-20 intermediate-range missile carries 3 warheads, and its launcher can be reloaded quickly. The SS-20's mobility poses a challenge to treaty verification that will be intensified as the Soviets deploy their rail-mounted SS-X-24 long-range missile. Even more elusive is the American cruise missile. The cruise can be launched from land, air, or sea, carrying nuclear or conventional payloads. Though not a first-strike weapon, the cruise is considered the most difficult challenge for treaty verification.
Cruise missiles are very difficult, very, very difficult to verify complete ban or even testing. Cruise missiles presumably will have nuclear warheads on them. But then you can't tell where this is a conventional one or a nuclear one. And the only way to avoid that confusion and uncertainty is to ban production of all of them, which I think the military will oppose with some reason. So I don't see a solution for the case of cruise missiles.
The cruise missile relies on a computerized mapping system. Information provided by satellite photography, much like that in L.A. the movie, assists in course corrections during flight. The result is pinpoint accuracy. In this test, a cruise missile carried a conventional warhead 240 miles to its target.
The guidance system of the cruise missile that we have now, the TERCOM system, depends on a very, very accurate mapping. And that indeed is another function of photo reconnaissance. So photo reconnaissance is like Jekyll and Hyde. It has peaceful applications, but also has very threatening applications. What you see here is exactly what we've been saying for a long time, namely that technology can be used any way we want to use it. The same technology, the same capabilities can be used to help combat and to help negotiated agreements with our opponents.
Throughout history, information gained from the high ground has been critical for warriors. It is now critical for peacemakers as well. As atomic arsenals continue to expand, any hope for arms reduction and the security it brings to our planet may rest in large measure with our spy machines. Yet it is no small irony that the machines that spy on nuclear weapons also are used as guidance systems to deliver those same weapons with deadly accuracy. The more capable reconnaissance systems become, the more accurate nuclear weapons can be. For today and the future, the missions of spy machines and weapons are intertwined, locked in a cycle of endless competition.
That's true. When the target becomes more difficult, like a small cruise missile is more difficult to detect than a great big intercontinental ballistic missile, an ICBM, you then have to start finding new techniques, new technical devices to find them. Maybe you can, maybe you can't. But That's the game of intelligence. There's moves to uncover and counter moves to cover. And it goes on endlessly.
Tomorrow at this time, settle back for an all-star evening at Pops with Andy Williams, Cleo Lane, Oscar Peterson, Ray Charles, and Peter, Paul, and Mary. Quite a lineup tomorrow, beginning at 7. Stay with us now. New project coming up on This Old House next.
For a transcript of this program, send $4 to Nova, Box 322, Boston, Massachusetts, 02134. Please be sure to include the show title. To purchase film or video copies of this program for educational use, call toll-free 1-800-621-2131. In Illinois or Alaska, call Collect, 312-940-1260. Major funding for Nova is provided by this station and other public television stations nationwide. Additional funding was provided by Allied Signal, a technology leader in aerospace, electronics, automotive products, and engineered materials. And by the Johnson & Johnson family of companies, supplying healthcare products worldwide.
Next on Nova. The first discovery in more than 400 years of a nearby exploding star, a supernova. From mountaintop observatories to deep in a mine shaft, the results have been startling as we try to understand the death of a star. That's next time on Nova.
Local broadcast of Nova is made possible by our members in partnership with the Genrad Foundation. Next at 8, watch This Old House as we bring a 1950s ranch-style home up to date. Then at 8:30, Shoes, an award-winning film by Harvard's Yul Kays on Say Brother. Mysteries at 9, Tommy and
Toledo Hospital because of poor